So first, I'm going to do a quick intro to set the stage and present the three sample studies that I'm going to present to show some examples of what we've done to complement the ideas that I'll be talking about. I will start, after introducing the sample studies, I'll start with some foundational concepts for experimental design that are, I think, key to always keeping in the back of your minds when you're designing experiments. And then I'm going to be talking about the planning approach. So what are some of the things we need to think about when it comes to measurement, when it comes to design, when it comes to sampling? And then I'll also mention a few thoughts on the execution. So pre-registering some of our design and approach, hypothesis, analysis techniques, and so on. And some of the things that we should be thinking about for data collection, and most importantly, to ensure that the data is of high quality that we're using in the experiment. So this is the agenda. Now I'm going to skip the intro since Chris did such a kind introduction, and I'll go straight to the three sample studies that we're going to be talking about. So I'm going to be referring to three studies that we are they're all in the current process of the review process right now in the journal review process, and I'll be showing some examples from these studies as the talk is ongoing. So the first one is a study on AI anthropomorphism and trust, and that was an online experiment. It was a between participant design. We did a 2x2x2, so three-factor design. We manipulated the social cues of AI agents. So we had we focused on some specific nonverbal cues and some verbal cues. And from that, we extracted the 2x2x2. So what were these cues? So in terms of the manipulation design, we manipulated the images. So we had avatars that people were interacting with in a specific context that we developed. So we had different types of avatar images, a more human-like image versus a more robot-like image. We also had an animated feature. So some of the avatars had like embodied animation and voice. So they were basically like, doing things like gesturing, moving lips, blinking, and so on. And we also manipulated the social communication style. So these were our 2x2x2. And the context is a personal financial investment. So every time we design an experiment, we have to think of a specific context in which the participants will get involved in the experiment. And we need to also think about to what extent this context can be generalizable to other contexts, or maybe not. Maybe our findings could be then restricted to that particular context. So in our case, it was like a robo-advisor, a financial advisor. So this is study one. In terms of study two, we were looking at social media misinformation. So the sample here were people who were on their day-to-day interactions exposed to social media posts, and they would then try to see if the posts are, if the message of the post is true or false. So typical like misinformation design. Very typical type of design. We did it in the lab for the main reason that we were also interested in studying not just what people say or do, but also we looked at, so we used eye tracking technology to look at as proxies for their attention, how which areas of interest they were looking at, for how long, how they were kind of moving across the different stimuli that were represented in the social media post. So for example, looking at the source versus looking at if there's hyperlinks present, if there's an image, all of these kind of things. Now, this technically could be done online, but you would have much less control in being able to really see what's going on online. So we did it in the lab. We had and we were also measuring emotions. So we were using like the facial features, the muscle movement in the face to infer emotional reactions. This was a within participant design. So I'm going to be talking about all of this between design and within participant design. We used repeated measures. So every participant would be exposed to 20 posts. And we also use the Latin square counterbalancing of the order of the posts. I'm going to be talking about all of this later and why we did that. What did we manipulate? So we manipulated different cues in the social media posts. So, you know, like some signals of, so we had the veracity. So some posts were true, were factually true versus factually false. We manipulated the source of the message, the level of professionalism by which the post is written, and a number of other cues. So the design here, every time you're trying to study the effect of X on Y, the causal effect of X on Y, you need to think about the design, the package within which the digital artifact is presented. And in our case, we decided to use Twitter or X style social media posts so that users would be very familiar with that kind of standardized post. And then we did variations in the source. We did variations in the, you know, whether some posts had images or not, whether they had hyperlinks or not, and then in the particular content of the post as well. So the context was really everyday usage of consuming social media posts. So our sample was more general. All right, study 3. Here we were interested in using generative AI in the context of a cognitive task where people had to write a particular type of text. And we measured learning and performance, basically. This was online, so that's an online experiment, and we had a single factor design. We had 5 levels for the different Gen AI modalities, which we call them, you know, like different ways of using generative AI. I'll talk about those details later as well. And then we had a 6th group, which was the no generative AI. So people would just write the article by themselves without the help of generative AI tools. So very simple ANOVA style single factor design, and it was between participants. So participants would only be exposed to the single task, and they were assigned to one of these modalities. So the manipulation was the modality type. So we had some generative AI tools act as a writer, so that, you know, the Gen AI would take control of the writing task from beginning to end. We had an editor modality. So here the human would write the post, but the Gen AI would polish it and improve it. And then we had a bunch of other designs as well, like sounding board, where the Gen AI would provide feedback to the writing and so on. So the design here, the manipulation design, is that we developed AI assistants using the OpenAI platform. So we connected to OpenAI from the back end using APIs. And we delivered this experience. The front end was basically a very standardized interaction on a website in which people could only access the generative AI. There was no access to anything else. They couldn't access their, you know, browsers. They couldn't access other materials. They could only interact with the Gen AI tool as we've designed it. So because we wanted to have very tight control on what they could or could not do. And the context here is knowledge work. So it was a writing task. Every time you design an experiment, you have to think really hard about the context and to what extent, like I said, this context would, you know, the people that you choose in your sample would be knowledgeable respondents. So they would be able to understand the context, use the artifact in that context, and you'd able also to make inferences that can be generalized to the population within that context or even beyond that context. All right, so with that said, let me start with the foundations. So I'm going to start talking about experiments, why we do them and how we do them. All right, so first of all, why? You know, why experimental designs? When you're conducting a research study, you have a specific research question that you're trying to answer. An experiment may or may not be the best tool to answer that question, all right? So when does it become a good tool? Why do we conduct experiment? It's pretty much when we're trying to estimate a causal effect. So we have X, we have Y, and we're trying to make a statement about causality that X is causing Y, all right? Now, causality is a very strong statement in social science research. It's a very risky when you're talking about causality. Because you need to establish 3 things and you need to establish them well. The first one is correlation. So you need to show that there's correlation between X and Y. The second one is temporal precedence. So you need to show that X happens before Y. So your manipulation occurs before you measure the outcome. And the third and trickiest one is that you need to do your best to rule out alternative explanations, okay? Because maybe you find that X is positively associated with Y, but there could be a bunch of other factors that you either thought about or didn't think about that could be driving the outcome. And X is masquerading as the independent variable, but there's actually something else going on that might be driving the outcome. All right, so that's very important. So your main goal is that you're trying to reduce the bias due to the confounding. All right, so you want to, as much as possible, be able to say that there's not something else that's biasing the effect that I'm measuring, biasing that coefficient upward or downward. Okay, you're trying to eliminate confounders. So what are those confounders? Let's look at a little simple example. So my X variable is the use of a collaboration tool, so using Slack or Twitter or LinkedIn tool, or that's I'm trying to see whether the use or the extent of use of a collaboration use will drive job satisfaction or not. So however you measure it, it could be the frequency of use, it could be the type of use, the extent of use. That's an operational question, right? Like how you measure use. But let's say I'm trying to see if by using the collaboration tool, employees will be more satisfied or less satisfied in their job. So very simple design. You have an X, you have a Y, you can show correlation, you can show that you can design an experiment in which maybe some people are using the tool, some people are not using the tool, and then you measure their satisfaction afterwards. So it's very easy to show the first and second thing. It's very easy to measure the correlation if it exists, and it's very easy to have temporal precedence because you designed the experiment and you're ensuring that the manipulation, which is the using the tool or not, happens before you measure the outcome. The third one is tricky, right? Because there could be other confounders, like for instance, social integration. Maybe the more socially integrated the employees are within that particular department or team or organization, that could be confounding. What does confounding mean? It means that it might be correlated with both the X and the Y. So maybe the more they're socially integrated, the more it becomes expected that they use the tool. And maybe social integration also has an effect on job satisfaction. So if you have this confound and you're not careful, it could be biasing your result, and you're now less confident in saying that the collaboration tool use actually caused job satisfaction. All right, so that could be a problem. Maybe there's another confound, maybe communication support, the infrastructure, maybe at the organization. Does it support, does it encourage communicating with your teammates, with other people within the team, across other teams, across functions or not? And again, maybe that particular infrastructure support might be affecting the tool use as well as the job satisfaction. So big problem. We have two confounders here that will undermine our trust in concluding or inferring that collaboration tool use has caused job satisfaction. All right. So how do we address this challenge? What do we do about these confounders? Well, we have at least three options. We could control them. So we could match, we could say, all right, let's have two groups. One group, we're going to, for each participant in that group who, let's say maybe one group that's using the collaboration tool, one group that's not using the tool. And then for each participant in group one, if they have a lot of communication support, let's try to find another participant and put them in group two that also have that level of communication support, right? So you're trying to kind of wash away the effect by matching the sample across your groups, so that then the communication support will not be the thing that's driving the effect, okay? So that's matching. Now, you could do that, but you have to first know the existence of that confound, and it's not that easy to do. This matching one by one is not very easy, that you find a perfectly or a near perfect matching sample for each of your data points. So it's not very practical. We could say, let's hold it constant. Let's only look at organizations that do provide communication support and social integration. And within this group of organizations, let's see if the use of collaboration tools drives job satisfaction. So we're holding the confound constant so that we don't have any variance in the confound. So if we find a relationship between collaboration tool use and job satisfaction, we know that it's not because of that confound. Okay, you could do that, but again, it's not that practical sometimes because how many confounders are you going to hold constant, right? And do you know about these confounders or not? And can you hold people constant? You can't really hold people's behaviors constant. So that's why a lot of times we use randomization because it allows us to randomly assign participants to the two groups, one group that uses collaboration tool, one group that doesn't use the collaboration tool. And then we say, whether we're worried about social integration or communication support, chances are that if we just randomly assign people, some people will land in the first group that have high and low, both, like all different levels of social integration. Similarly, in group two, we'll have also a mix of people with low and high and medium social integration. So we're trying to cancel out or average out the effect in that way. Okay. So randomization is a really cool tool because it allows us to ensure that the alternative causes are not confounded with the treatment condition. Okay, so it's very effective a lot of the time, not all of the time, but a lot of the time in reducing the plausibility of threats to validity because it distributes them randomly over the condition. Now, the most interesting thing when you look at randomization compared to the other options is that you don't have to know beforehand all the confounders, right? Because whatever the confounding might be, the chances are that it's going to be randomly distributed across the groups. So it's not going to have a big confounding effect on the outcome. So that's why random assignment is a very big thing when it comes to experiments. Now, how do we know that the randomization actually worked? Because the randomization, it equates to groups on the expected value of all the variables. Okay, the expected value, not the actual value. We don't know what the actual value would be before we assign participants to their groups. So in theory, it should work, but in practice, it might not always work because of the coin toss. Because maybe it happened, and in this particular assignment to group one and group two, you just got unlucky, and it turned out that one group had high social integration, one group had low social integration. So the confound might still happen just because of bad luck. All right, so we need sometimes to check that the randomization has actually worked, which is something I'll also talk about later. All right, so now how do we do this practically? So if we want to do random assignment in Qualtrics, for example, many of us use Qualtrics when we're designing experiments because the manipulation itself is one thing, but Qualtrics can handle the random assignments. And of course, in experiments, oftentimes you're not just manipulating the independent variable, but you're also measuring the outcome, the dependent variable, or maybe if you have other covariates or mediating effects, or however your model might look like, you can measure those things in Qualtrics. So I use Qualtrics quite a bit, and typically I just add in the survey flow, I add a randomizer, and I set embedded data. So for instance, here, this is from study one, AI anthropomorphism. And remember, it was a 2x2x2. So we had two levels of social communication. We had two levels of appearance, which I called here face. And we had two levels of animation and voice, which is called here voice. So you can set embedded data in Qualtrics so that the randomizer would assign every participant randomly to one of your in this case, 8 different groups because it's 2x2x2. Okay. So this is what a design typically looks like. You have, first you have your research question about the population. You draw your sample from the population. Hopefully, the sample is representative of the population. This is a very, very big topic, and it's not always the case that the sample is representative. And it's a huge problem because if it's not, then you're making inferences about a group of people that is not generalizable to the population, right? Typically, we want to generalize to the population. So you do your random assignment. So some people will be assigned to group 1, some people will be assigned to group 2. And then once you've randomized, you can then apply your treatment. So, group 1 takes the treatment condition. Group 2 takes no treatment. So that's the control condition. And then, so that's the manipulation step. And then the measure step is where you measure the actual outcome. Okay, so you want to see if the treatment has worked or not relative to the control group. So this is how we typically show it. If you're showing the design, the X is the manipulation, and then O is the observed outcome. And then the line here shows your two groups. So the top group has received the treatment. The bottom group has received no treatment. So that's the control group, right? So that's a basic randomized design, comparing the treatment to the control. Now, another variant of this is you can have a factorial design. Okay, so instead of just saying, for example, here we could say the X is whether the group used a generative AI or not. So I provided generative AI to one group and withheld it from the second group. So that would be here. Okay. Factorial design is a bit different. So if we have, let's say here we have 2 by 2, so two factors A and B. Every participant will be assigned to a group such that they experience a level of both factors, right? So here, for instance, if you're assigned here, you will get level 1 from the A factor and level 1 from the B factor. Here, you get level 1 from A, level 2 from B, A2, B1, A2, B2, okay? So here, for instance, if you have a factor with 2 levels, like appearance, human-like versus robot-like, okay? And here, let's say we have social communication, high versus low. So you might be assigned to this group, which has human appearance, but low social communication, all right? So what's the advantage of this, of a factorial design? Well, it's very efficient because if you think about it, every participant is playing 2 roles. It's kind of like wearing 2 hats. They get exposed to A, but they also get exposed to B, right? So you can make a statement about comparing the 2 levels of A, but also the 2 levels of B from within the same participant, right? So it's a very efficient type of design, and typically you need a lower sample size because of this double duty that the participants play. So that's a factorial design. So let's look at a simple example here. So this is from Young et al., like a typical example used to show a 2-factor experiment. So here we have 2 factors, belief and outcome. So belief could be neutral or negative, and outcome could be also negative or neutral, okay? So those were the manipulations. People were assigned to one of 4 groups, one of 4 possible groups. And the scenario here is that it's a vignette study. So you read the scenario and then you make your judgment, okay? So if you're assigned to this group, the belief is negative and the outcome is negative, you will read this scenario. You would say, Grace thinks that the powder is toxic, and it is toxic, and her friend dies, okay? So the belief here is negative, because Grace, who's here like the person, like the main actor in this case, thinks that the powder is toxic, and it is actually toxic, and then her friend dies, right? So the belief is negative because she thinks it's toxic, and the outcome is negative because it's in fact toxic and the friend dies, okay? So that's the manipulation. That's what you hear. That's what you read. And then the outcome is permissibility. So you have to answer a question from 1 to 4 in which you say, how permissible is this action that Grace did to her friend? Okay. Is it highly permissible? You give a score of 4, or is it forbidden? You give a score of 1, or somewhere in between. So this is the measured outcome. Okay. Now the belief could be neutral and the outcome neutral. So Grace thinks the powder is sugar, and it's actually sugar, and her friend is fine. So then we take, people in that group would also rate the outcome. And then we have the mix, right? So the belief is neutral. So Grace thinks that it's toxic. The belief is negative. So Grace thinks it's toxic, but it turns out to be sugar. Her friend is fine. And here the belief is neutral. So Grace thinks it's sugar, but it's not sugar. It's toxic, and her friend dies. Okay. And then you measure basically the permissibility in each of those 4 conditions. So let's see what's happening here if we're trying to measure the effects in these 2-factor experiments. So first, we have a reference group, which is belief is neutral. So that's the blue bar, and outcome is neutral. Okay, so that's the left side. So not surprisingly, this is a very unsurprising result, is that if the belief is neutral, outcome is neutral, most people will score close to 4 because that's permissible, right? You think it's sugar, you give the sugary drink, or the powder to your friend, and she drinks it, and she doesn't die because it's sugar, right? So that's fine. You get close to 4. Then let's see what happens here. So if we want to measure the simple effect of belief, now what happens when the belief switches to negative? So the outcome is still neutral, but the belief switches to negative. So that's the simple effect. You can see a huge drop. The simple effect of belief is minus 2.7. So if Grace thinks that like here, Grace thinks that, this is the negative belief. So here, Grace thinks that it's toxic, but her friend gets lucky and doesn't die, right? But the idea is that Grace gave her the drink when she thought it was toxic. So of course, people would score much lower on the permissibility outcome, right? So the simple effect is quite big of belief. When you switch from the reference group to the negative belief, you get a drop of minus 2.7. All right. So, we started from 3.9 reference group. Now we dropped by 2.7. Let's look at the simple effect of outcome. So just by switching the outcome from neutral to negative, so that when we're comparing the 2 blue bars here, we get a drop of minus 0.7. So just the fact, even though Grace thought that the powder is sugar, but because the friend got unlucky and died, we have this drop, but it's not a big drop. It's minus 0.7. That's the simple effect of outcome, right? So if we add the 2 simple effects, minus 2.7 and minus 0.7, we will get here. We will get to this point. Okay, but notice that when we switch both the belief and the outcome, we are here. So this is the interaction effect. So this is interesting because the interaction effect is actually softer. When you switch the belief from neutral to negative, and when you switch the outcome from neutral to negative, the interaction, instead of making the outcome worse, it makes it less worse. So the observed outcome here is 1. Okay. So this is a very interesting case because you're like, how does this make any sense? Shouldn't the interaction make it worse? Well, if you look closely at what's going on here, we've already reached the floor because the survey measures the permissibility from 1 to 4. There's no answer below 1, right? You can't answer 0. You can't answer 0.2. Your minimum is 1. So the fact that the interaction here was positive, not negative, is because of that floor effect in the study. So that's a very, very big and important insight, I would argue, because, sometimes you think the interaction is doing one thing, but actually what's driving this interaction effect is the fact that you've reached the floor. So you can't go lower than the floor outcome. Okay. So I wanted to show this as kind of, how do we make sense of simple effects and interactions? I'm going to skip this slide. This is just a different way of showing the same thing and comparing the simple effect to the main effect. The main effect is different because it's the average across the outcomes. Okay. The simple effect is happens within a specific outcome. So that's why I fixed on the reference group. All right. So let's talk about some of the issues we need to worry about when we're conducting experiment. Like, it's very important to think about validity. Okay. So what is validity? How close to the truth is our inference? So ultimately, we're trying to make an inference about the effect of X on Y that's close to the truth, right? The truth is out there. We don't know it because the truth is in the population. We don't have access to the entire population. So we hope that our inference is as close as possible to the ultimate truth. There's different types of validity. There's statistical conclusion validity. So basically, did we correctly conclude that the treatment and outcome are related? So if we find the positive effect of X and Y, is it actually a positive effect, or did we get lucky because of chance? Or maybe did we violate an assumption in our test, and it violates the statistical conclusion validity? Okay, or did we do p-hacking? Did we keep trying until we got a significant p-value? We don't want that. Internal validity is the outcome really caused by the treatment and not by something else? Okay, so again, it might look that X affected Y, but maybe there's something else, a confound, that is actually driving that outcome. Or maybe there's a missing variable we didn't measure that is, that's confusing that outcome. Construct validity: do our measures and manipulations capture the concept that we claim they do? So we might talk about satisfaction, but are we actually measuring satisfaction? Or did we use an instrument or a scale that doesn't represent satisfaction? Like maybe the experimental result looks great, but if I'm not actually measuring the concept of satisfaction, then I have a problem, which is construct validity. And then external validity is, does my experiment allow me to say something about outside of that sample that I tested, right? So is it generalizable? Does it have value beyond that particular sample? Is it going to hold across different people, across different settings, different treatments, and different measures? So those are all, when you're conducting experiment, you need to think about those 4 types of validity. Now let's look at what could threaten or undermine the validity, right? So there's different threats. There's selection threat. So that's a very tricky one, because sometimes the selection bias could happen when the groups differ systematically at the baseline, and those differences are actually what's driving the outcome. So the example here is maybe Kumon, Kumon, which is kind of like tutoring practices and math tests and things like that. Let's say you're trying to measure the effects of Kumon, which is a service that helps students in their math, improve their math and other things. But if you're comparing group of Kumon and non-Kumon, what about, the fact that parents are actually choosing who goes to the Kumon class? That's a selection bias, because it might not be Kumon's effect, but it might be other things, maybe because the parents chose their kids to attend the Kumon classes, maybe that means they're more motivated, maybe they provide them more support, they do other things that you haven't measured and you're not aware of. So that could confound with the effect, okay? History is if something happens over time that could be concurrently occurring with the treatment that might cause the outcome. So for instance, in our social media misinformation study, it could be that something happened, like an event happened at the same time. Like there was a big media coverage, something about, huge scandal about like fake news that has huge implications politically, for instance, or something like that. So that could have sensitized people that took your experiment, and you're making statements about those people, but there's something that happened at the same time externally that could create this bias. Maturation happens when, as the time unfolds during the experiment. So maybe people are exposed to multiple things and they get tired, they get fatigued, they learn something about your experiment, which could be affecting the outcome. All right, we have other types. We have regression bias as well. So here, for instance, let's say you measure extreme scores. So for instance, let's say we have, I'm measuring people sharing misinformation posts, but I have 500 users who share the most misinformation. So these are like heavy conspiracy theorists, let's say. Um, if I measure those people, maybe in the future, they don't have much room to move, right? So that's again that kind of floor and ceiling effect. So I might experience regression to the mean because they're already at an extreme level. So it might regress back to the mean, and that can affect the outcome. Attrition is this is when you're doing an experiment, you have several measurements over time, and people don't complete all the different phases. And that could be a problem, especially if the reason why they quit is related to your manipulations. Okay. So a typical example, let's say you're studying, addiction, and you have two treatments. One group of addicts are doing discussion groups where they sit in circles and talk about these issues. Another group is doing family therapy, where they have to go with their family and talk with the therapist directly. So the sicker addicts group drops out of the discussion groups more than the family therapy. So it leaves kind of, like the hardest addiction cases in one group, but it happened because of attrition. So whatever you conclude about the effectiveness of the intervention might be confounded by the attrition. And then finally, testing. So this is the typical Hawthorne effect when, being tested affects your answers. Okay. So for instance, if let's say in a misinformation study, if there's two measures, the first measure makes people become more vigilant, maybe, so they pay more attention, and that can pollute the second measure. All right. So what are the elements of experimental design? You have to think about assignment, so random assignment or non-random assignment. I talked about that. You have to talk about your measurements. Like, is it a single measure or is it multiple measures across time? You have to think about your comparison groups. Is it a single non-equivalent group, or you have multiple comparison groups, or do you have a cohort that you're watching kind of over time, like a group of people in a class that graduate and then another group joins? And you have to think about your treatment. Is it a single treatment, or do you have other kind of designs like switching replications, repeated treatments, or remove treatments, where maybe you give one group the treatment, you measure the outcome, and then you take the treatment away and then measure the outcome again. So that's used in clinical studies and so on. All right. Now, a key thing when you're designing your treatment is don't always assume that the participants will listen and adhere to the treatment, right? So if you're assigning them, so that's something, for example, like when we faced that problem, when we did the Gen AI study, so we assigned people to different groups. Some groups could use the generative AI assistant in one way, one modality, like to write the entire article or to provide only feedback on the article and so on. We have to make sure that people actually adhere to that condition, okay? Sometimes it's by asking them to do it, but more often than not, you have to design the environment in such a way that you maximize the adherence. So you take away things they're not allowed to do. You take away access to a browser. You design the Gen AI that it's not able to write for instance, the essay if it's in the condition where it's only supposed to provide feedback. So you can make, like design the prompt in a way, or design the agent in a way in the system prompt that it can only do things and not other things. So adherence is very important, and manipulation checks, which I'll talk about, can allow you to see that if people adhered and experienced the treatment as they're supposed to or not. All right. Okay, so this covers the foundation. Let me talk now about planning, and I'm going to start with measurement, and then I'll talk about design, and then I'll talk about sampling. So measurement, I really like this quote from David Kenny, who is a social psychologist, and he wrote a bunch of very excellent books on quantitative methodology. This about measurement, so Kenny said 2 might be fine, 2 items, 3 is better, 4 is best, and anything more is gravy. All right, so it might be a bit extreme. Like obviously, there's no one recipe that tells you how many items in a particular scale or for measuring a particular construct is correct. And there's huge debates, which I'm not going to get into. Sometimes, there's debates in the social science fields about is it good to use a single measure or do you have to use multiple measures? I found that for most practical purposes, that having multiple measures is good because it allows you to measure averages. It allows you to measure reliability of the measures. It allows you to measure, convergent and discriminant validity, and so on. Okay. Three is better than two. So that's the advice here, is because three allows the model to be identified. Four is better because it's over-identified. So you can have more degrees of freedom when you're doing your measurement model. And sometimes you design your measures for a construct and you find that when you're testing them, some measures don't perform that well. And then you start considering if you should drop a measure or so from your construct, but that has to be done very carefully. So when you're doing measurements, these are I brought together a list of bullets that I think, advice that I always follow. First of all, you have to sample the content domain of the construct. All right. So for instance, if I'm measuring trust, like I did in study one, what is the content of that construct of trust? Is it unidimensional or multidimensional? Trust is typically multidimensional. So it has, like a lot of trust measures. They talk about 3 dimensions of trust: competence, integrity, and benevolence. For each of the 3 dimensions, you have to have a sample of items that taps into those 3 dimensions. So that's very important. You need to ensure that the measures are valid and they're reliable. And there are tests that allow you to measure reliability and validity, convergent validity, discriminant validity, and so on. Reliability is important, but it could also be a problem. So I see sometimes papers where the authors are very happy because they get reliability, Cronbach alpha score 0.97. But to me, that's actually a signal that there might be a problem in these measures. The measures might not really be capturing different shades of the meaning of the construct. It's basically asking the same question 5 times, and that's why the reliability is so high. So it kind of defies some of the reasons in psychometric design of measurements of why we want to have multiple items per construct. You want to use validated measures where feasible, so try to avoid reinventing the wheel. And sometimes you need to adapt those validated measures to your context, but it has to be done extremely carefully because these measures have been validated and they went through a rigorous list of steps in order to be valid. So if you just take them and start changing the words randomly, it's going to be a problem unless you restart the validation process again. Which brings me to this point. So if you develop new measures or significantly adapt an existing measure, then you want to do some tests to revalidate those measures. Multiple items per construct. So I talked about that one. And avoid the temptation to measure too many things because a lot of problems will happen in your experiment design, right? Again, a lot of experiments, you have your manipulation, and then you have a bunch of measured covariates or outcomes. If you're measuring too much, it's going to be a problem. It can lead to fatigue. It can lead to careless responding. It can lead to multicollinearity, so lots of things correlating together. Like could be maybe covariates that are correlated together that might be affecting the predictions with regard to the outcome. The positioning of the measures in the survey has to be done strategically. So what do you ask first? And there's excellent references. I'm going to share some references with you shortly about this. There's lots of debates about what should you ask first in the survey versus what should go last. I tend to prefer to ask the most important questions toward the beginning of the survey so that if I have less engagement later on, it happens on the less important questions as opposed to the most critical or core concepts that I'm trying to measure in my model. You want to also visualize the distribution of the responses across items within the same construct and as also across constructs. Okay, so you want to do like your typical EDA, exploratory data analysis. Scan for outliers. If you find outliers, ask yourself, what do we do about them? Do we keep them? Do we replace them? We start thinking about imputation, which sometimes helps, but it could have huge problems as well. or do we do, some kind of with and without sensitivity analysis and so on? Dropping items should be done carefully and mindfully. So I never like to drop items just because of their statistical properties or because dropping it will give me better reliability scores. Because by dropping an item, you might be losing in this part, which is tapping the content domain of the construct. So by dropping an item, if you have 3 items or 4 items and you drop one, you have to ensure that you're still tapping into the entire domain of the content of what that construct actually means. Okay, so these are 3 papers that I really like to recommend and read myself whenever I'm creating measures. The study by Potsakov and colleagues on concept definitions and measurement so this was published in Organization Research Methods. This is one from IS, Mackenzie et al., also a classic reading, 2011, on construct measurement and validation. And this is an excellent book by Leor Gideon on survey methodology. And it talks about lots of these issues that I've discussed. All right, let me switch to design. So let's talk about designing the different elements of the experiment. So typically, the 3 elements of an interpretable design are the pre-measurement, the post-measurement, and the control group. Right, so let's look at examples. So here we have, the basic setup that I talked about. So we have a basic randomized design that compares the treatment to the control group. Okay, here we have the same design, but we are comparing 2 treatments. So treatment A versus treatment B, no control group. Okay, you could add a control group, of course, which is this case. So here we have treatment A, treatment B, and then this is the control. Here we have the factorial design that I talked about earlier. So 2 factors, 2 levels. A has 1 and 2, and B has 1 and 2. And then we have some interesting other possible designs. So this one is a design where we have the pre-measures and the post-measures. So at time 1, we're measuring, the baseline measure of the outcome that we're interested in. Okay, so both groups are measured at the baseline. And then one group gets the treatment, one group doesn't. And then we measure the outcome again. So these are the post measurements. Okay. So why do we do this? So that's kind of like, the difference in difference, because we want to see, is the effect we observe at time 2 because of the treatment or because of something that was already there in place before the treatment? So that's why we're taking these baseline measures as well. Okay. Now you can add to this even these 2 additional groups. So that's called the Solomon 4-group design. So that's kind of like a classic in experimental design. So now not only are we measuring the pre and post, the baseline, which is the pre-measurements, but we're also adding 2 groups that are only tested in the post measures, not in the pre-measures. Okay. So here, what we're doing now is we're separating the treatment effect from any influence of the pre-measures itself, because this is the pre-measures. We can compare what happened in terms of the effect from the groups that had the pre-measures to the 2 groups that did not have the pre-measures. Okay, so this allows us to have more confidence in our results. This is a different one. So this is called switching replications. So we have 2 groups. We have pre-measures. So at time 1, both groups get measured. And then we administer the treatment to one group. And then we measure the outcome. And then we switch. So now group 2, which was waiting at this time, now gets the treatment, whereas group 1 is now the group that's not getting the treatment. Okay, so that's called switching replication design, and you can do it with factors as well. So group 1 gets factor A, while group 2 gets factor B, and now they switch it. So this is called switching replications. Why do we do this? Because it can give you higher power, because every person is acting as their own control because you're measuring them once before and twice after. This one is being measured twice before and once after the intervention. What are we paying in terms of cost? Now we have a potential problem with the order of the treatment. Okay, the order can confound with the treatment that you're administering. So you have to think about the order effect, and then there could also be other issues going on like fatigue, carryover effects, and something like that. So how can we deal with the order effect? One very common technique is counterbalancing. So we turn this order into a noise. So some groups will see, the first factor first, let's say, and some groups see the first factor second. So you do kind of a counterbalancing of the order. So let me show you why this is what's going on here. First, before I talk about the quarter effect, let me talk about what happens when we're just randomizing versus when we're doing within participant design. Randomizations controls bias, and within participant controls variance. All right. So let's look at this simple example. So let's imagine I'm trying to measure the detection accuracy. So detecting false news or misinformation in a post, let's say. Okay. So I'm trying to see the percentage of times in which my detection accuracy as percentage. Okay. Let's also say that we have people with naturally high skepticism, medium level of skepticism, and low level of skepticism. So that's kind of like a natural trait in people. All right. I'm not interested in that. So that's not part of my design. So in this particular setting where we have just random assignment, so we have condition A and condition B, and I'm measuring the outcome. So the outcome is detection accuracy. Okay, so 90, this one gets 90, this one 70, 55, 50. In the second group, we have 57, 97, 61, and 70. Okay, so we can get the average in each group. So notice that the people with higher skepticism tend to score higher. So this one got 90. This one is also higher, so got 70. This one is also higher, so got 97. So there is this variance within each group because of the skepticism. But if I measure the treatment effect, it's 5. Like the average difference in these two samples, at least, it's about 5. Standard deviation is high because we have in each group that kind of people have high, have low, have medium skepticism. So standard deviation here is about 18. Now, why might we want to say let's do within participant design, which is this setting right there? Well, because each person can become their own control. So we have the same 8 people here. So we have N1 to N8. So this is N1. This is, person data point number 1. That's the same person as this one, except that this one, we're measuring that person with the high skepticism twice. So on the first condition, the result was 90. On the second condition for the same person, the result was 95. So delta is 4. All right. So what are we doing here? Each person becomes their own control so that we are basically reducing the noise substantially. Okay. So notice here that the treatment effect is still around 5 if we take an average here. But now the standard deviation is much lower because we're allowing each person to act as their own control. So this gives you a smaller standard error in the sample. It gives you more power to detect the effects as well. All right. I'm going to skip this at the interest of time, but it's useful when you look at this later on to see the pros and cons of the within participant design, which is on the right side, compared to the between participant design, which is on the left side. Okay, then happy to talk about it later. All right, so the order effect is important to control. If we have between design, there's no order effect because each person just sees the treatment once. The minute you start introducing multiple measures, or people are seeing multiple manipulations, the order by which they see it might be a problem. Okay, so how do we deal with that? Well, you could say, let's just randomize the order. So, if the order, for instance, I'll give you an example here for our social media misinformation study. Each person would be exposed to 20 social media posts, and they had to decide, is this true, is this false? Okay. All right. If I were to say, let's randomize the order so that every possible combination of 20 posts becomes shown to the participants, that's impossible because it's going to give you 2 quintillion different combinations. All right. It's just simply not possible. So that's, when this becomes prohibitive, one thing you could do is what we actually did in this study is we did a Latin square design. So we're not going to show every possible combination of order, but we're going to say, let's rotate so that every post takes the position once in one possible order. So this is what you can see here. So we have 20 posts. So we have 20 participants and 20 posts. Okay, so participant 1 gets to see this order. So the first post participant 1 sees is post number 12, and then they see post number 5, and then they see post number 13, and so on. Okay, participant 2, let's just rotate it. So participant 2 starts with 11, which was the last one here. So the last becomes the first becomes the second becomes the third. So we are just simply rotating the order of the post so that every post, so post number 12, will be shown at least once in a different order. So see, it's shown once in order 1, once in order 2, once in order 4, 3, and so on. So that's called Latin square. Okay, it's not showing every post is not, not every possible combination of the orders, but it's still much more efficient, and it helps to a large extent to manage the order effects. And you can conclude with more confidence that the order by which people saw the posts is not confounding with the treatment itself that you're trying to administer. All right. Okay, let me talk about sampling now. So with sampling, the idea is that you're trying to measure a causal effect, right? So you're taking your sample, but for whom? Who are those people in your sample, which is critical, right? And are they representative of the population or not? So there's 2 general techniques. You can have probability sample, like simple random sampling when you're trying to draw from the population at random, or there's non-probability sampling, which is the overwhelming majority of study is using non-probability sampling, like convenience sampling. Okay. So this is an interesting quote in the 40s. The existing science of human behavior is largely the science of the behavior of sophomores, right? So if you think about a lot of the behavioral studies in IS and different management-related fields and social science and psychology, you rely on samples that are easy to get, convenient samples of university students, sophomores, or like second year, third year students. So the challenge with this, of course, is that to what extent is the behavior of these people representative of the phenomena that you're trying to study, right? Maybe it is. Maybe it's completely fine. Maybe it's not. So you have to ask these questions. And pay attention to the weird problem, right? Because a lot of the overwhelming majority of studies that we read are from Western educated, industrialized populations, rich, democratic, right? So it's a very kind of narrow combination of factors that we're studying. But obviously the world is much richer than that. And inferences can look very different when you're studying a different group of people. Okay. So convenience samples do not always lead to bias. So that's important to know. This is here a representative sample where you have, different groups kind of, tend to occur relatively evenly, versus a convenience sample, which might be overrepresented by, let's say here, it's the blue group. Okay. It might not be a problem because here you see that the distribution of the effects in the population across the three groups, even though you have here overrepresentation by the blue group, but still the average effect tends to, so the average mean in the sample, the mean in the sample tends to be close to the population mean, even though it's a convenience sample, okay? Now, if the distribution is different, that's where it could become a problem. So here we have the bias because the sample mean is far away. So this is the sample mean, and this is the population mean. So that's, you know, when it could become a problem when you have a convenience sample in your study. So you have to ask yourself, if you're going to do a convenience sample, these two questions: is there a reason to expect my effect to vary across the subgroups? And if yes, is my convenience sample overrepresenting one of those subgroups? So you have to ask these questions ahead of time and try to design your study as such as to minimize those effects when possible. Okay. So sample size planning is also very important. What is the proper sample size? One thing that I like to advise and follow myself is to share your sample size in the study pre-registration. Okay, I'll talk about pre-registration. I think it's extremely important, especially if you're doing a confirmatory study. You have a specific research question, you have a hypothesis in mind, and you're just designing an experiment to test those hypotheses, that you announce beforehand in a pre-registered study what your sample size is, so that you don't, you know, try to fish for a larger sample or try to increase the sample size if you're not finding the effects that you're trying to find. Okay. Power analysis is important. So trying to measure before you conduct the study, depending on a specific power to detect the effect. Let's, you know, 80% is typical. Sometimes it's advised to go 90%. What's the sample size that will allow you to give you 90% or 80% power to detect a particular effect size? All right. So how do you know the effect size? Well, you know, you ask, you know, questions from maybe previous studies, from meta-analysis. If I want to detect effect size of 0.2, for instance, what is the minimum sample size that I need to be able to detect that size? Okay. So bigger sample size, statistically, it constricts the distribution so that you have a lower standard error, which means that you are more likely to detect a true effect if it exists. All right, so there are tools out there that help you with the power analysis to know how what's your minimum sample size. So this is one that I've used. It's called GPower. It's freely available, and depending on the specific analysis that you're doing, it tells you your minimum sample size. So, for example, I had one study one, which was on AI anthropomorphism, where it had a bunch of analysis. One of them was the 2x2, like factorial ANOVA. So you say, I want to do an F test with ANOVA. My effect size is, let's say, 0.12. That's, you know, that I know from meta-analysis or from prior studies or from my expectations. And it determines the minimum sample size that you need. Okay. And then in the same study, I had also indirect effects because I was measuring in mediation. Mediation effects tend to be smaller. So notice that I have a smaller effect size here because you're measuring the indirect effect. And then this is like a regression type analysis. And the minimum sample size is 150. So this gives you some insights into how much your minimum sample size should be. Okay. All right, I'll move to execution now. Some ideas about executing the study, and I know there are likely questions, so I'll try to also take some questions after this. I want to talk about pre-registration, ethical participation, research experience, and data quality. So pre-registration, like I said, I think it's extremely important, especially if you are conducting a confirmatory study. All right. What do you pre-register? You can pre-register your hypothesis. You can pre-register your design. You can pre-register your sample size. You can pre-register your analysis plan. So basically, I'll talk about it in the next slide, but let me just provide an overview. So pre-registration. Second thing is designing for ethical human participation. Okay, so when you're sending, like if you're conducting a study with human participants, you want to get all the ethics approval. You need to start early because there will likely be lots of iterations. You need to think about how you're making this study safe for your participant, informed consent, debriefing, and so on. Designing the experience itself. So you think to ask questions about lab versus online, and you need to ask questions about how do we screen, how do we design the context, the scenario, how do we compensate participants, and finally, how do we ensure that the data is high quality? All right. So let me go quickly one by one. So pre-registration. Why do we do it? Because it allows you to declare. You're telling the world what you're planning to do, because it puts you kind of in a pre-commitment. It puts you in a bind before you conduct the study. So it's better for transparency. It's better for credibility. It reduces the researcher degrees of freedom. So it kind of, commits you to what you should do based on what you said you'll do. And it protects you against p-hacking and harking. All right. So it kind of, reduces the temptation or the suspicion even from reviewers to think that there might have been p-hacking going on, repeating the study until you find significant effects, or harking, hypothesizing after the results are known. Okay, so there are different platforms that allow you to pre-register. Aspredicted.org. There's also the Open Science Foundation platform. For example, we've used As Predicted in one of the studies, study 1 that I've been talking about, where it's an easy form to fill, where you talk about the data, has it been collected or not? What's the main research question? What are your DVs? What are your conditions? How will they be assigned? How will you conducting analysis? How will you handle outliers? So it kind of forces you to think beforehand about all of the things that you're planning to do later once you have your once you conduct your study. Okay, and then the last one is about the sample size. All right, ethical participation. So like I said, you need to think about how to do this study ethically. How will your letter of information and consent look like? One thing that I often try to do is I want to be transparent to the participants in the study, but at the same time, I don't want to reveal to them what my hypotheses and manipulations are, right? Otherwise, it completely invalidates my results. So I don't want to tell them that, this is a study about misinformation. You will see 10 true posts and 10 false posts, and, you'll see this and that, because that then it becomes meaningless measuring the outcome. So you want to give them a sense of what the study is about, what they're going to experience, but without revealing the hypothesis. And of course, the debriefing can then explain to them what you've done and what to expect and so on. Some studies involve deception. So it could be approved if it's critical to your study, as long as it's, doesn't pose like significant risks, and that you address it in the debrief, right? So you have to get obviously ethics approval for that. In the letter of information and consent, you have to talk about how much time is involved, risks and benefits, compensation, confidentiality, how the data will be managed, and what's the data life cycle, what will happen at the end, participants' rights, the right not to answer questions, the right to withdraw from the study, as well as contact information of the authors, and getting explicit or implicit consent. All right, so this is just a sample of the consent information for one of the studies. Debriefing can be done synchronously, or more typical than not, I would say it's done asynchronously. So what do you do in the debrief? There's a bunch of things you can do. First of all, of course, you should share, you should thank the participants for their participation, and also provide them compensation if your study promised compensation, whether it's monetary or credit for courses or so on. You discuss the study goals. You explain if you've used deception, why and how you've used it. You provide a chance for clarifying, for questions if possible, and sharing the aggregate results. So this is extremely important. And sometimes, you ask participants if they'd like to get a copy of the results. If you give them that opportunity, then you actually have to share a copy of the results later on. It could be like a one pager. It could be something that's relevant for practitioners, but don't forget to do it if you've promised it. All right, research experience. So designing the experience itself. So online experiments versus lab experiments is a big question. If you're doing something on MTurk or if you're doing something on Prolific, is the data going to be high quality or low quality? How do we make sure? There's lots of studies about this. There's different findings. There's some evidence showing that if the study is designed right, there's no reason to expect that online panels will give you lower quality than in-person lab experiments. Ultimately, I think it's about your research question. What is important for the research question to answer it? And then you make your choice. And then whether you choose lab or online, you have to do your best to control the environment to the extent that it helps your research question, and try as much as possible to reduce outside things that could undermine the validity of your results. So lab versus online, you want to ask the following questions. The population. Are representative samples more readily available in person or online? So practically speaking. Measures. Is administering the measures online easy and accurate, right? So for example, in our misinformation study, we could have done eye tracking online. Of course, it requires like special eye tracking devices to purchase them, but we were worried about the accuracy that we'd get from this online. So that's why we did it in the lab. Okay. Manipulations. Does your manipulation require something beyond the browser window? If there's something, let's say, for example, I did a study where we were observing groups as they were discussing, using IT and discussing something regarding that discussion. And it was important for us to observe these discussions, including the covert behaviors, the nonverbal behaviors, in a controlled setting. So our manipulation required that we see something happening beyond just somebody sitting on a browser and answering stuff. So we decided to go for lab experience, not online. Ethical considerations. So online studies can be vulnerable to challenges, compensation and payments and things like that. But now it's become easier with platforms like Prolific, for instance. And also studies involving sensitive content or deception might sometimes require in-person presence, because you could then explain better, you can justify better, you can put the participants more at ease, perhaps at the debriefing, and so on. Okay. So for the lab, something that I did recently with my PhD student is, so this was the study where we had eye tracking and we were doing the facial expression. There was a lot of behind the scene work to look at everything. How big should the monitor be that people are looking at? Because we're tracking their eyes. Where should the camera be positioned? How about the lighting? We experimented with different lighting and intensity of lighting, positioning of the lighting, ergonomics of the chair, tons of things, tons of design decisions that we had to, test before we actually conducted the experiment. It's important that you design every part of the experiment. It's important that you design the script. It's important that you standardize the interaction so that people with different needs might have similar experience, whether, some people are colorblind, some people have challenges with, glasses, no glasses. So you need to think about all of those things and also document them. Extremely important that you document everything you've done for reproducibility. And also if you need to go back to that to see what you did and answer reviewer questions and so on. All right, online. So sometimes it's important, especially if you have different design components in your study, that you think about how the data will be linked. So something like some clever technique we used in study one, AI anthropomorphism, is that there was different components. There was like an interaction with an AI agent, and then there was like a survey that participants had to complete after the interaction, and then there was one before the interaction. So 3 different elements. We created like a random access code, and then we used JavaScript to match this code across the different interactions. So this allows us to understand, put together the answers across the three elements for each participant. And at the same time, we used it for realism. So we told participants, you're going to be given, when they were doing the pre-measurement survey, you're going to be given an access code. When you see the AI agent, please provide them the access code, because this will allow the AI agent to retrieve your financial portfolio. So we made it kind of part of the game, part of the context that we were designing, as being in the, imagining that you're interacting with a financial advisor who wants to retrieve your file to see your information. There was none of that, of course. It was a scenario, it was fictitious, but people had to imagine that they, had inherited money and they were going to be using a robo-advisor to invest it. Control the technical environment. So, for example, in study 1, we had to make sure that some browser did not work well with the experience for the AI agent. So that's something that we could control in Qualtrics. We told participants, don't use Safari, don't use Microsoft Internet Explorer. And that's something that you could control in the answers. And then also don't use mobile devices. You had to sit on a laptop or fixed screen so that the interaction happens in the way that we wanted it to happen. In study 3, with the generative AI modalities, we also controlled it so that participants could only see the chat window, nothing else in their environment they could have access to. Okay. We removed the documentation. So we gave them some writing task documentation, but once it came to the writing, we removed that. They could no longer access it, so that it could not pollute their learning outcomes that we were measuring later on. When you're thinking of screening, there are different things you screen for: location, demographics, level of knowledge, very important, because you're assuming that those respondents are knowledgeable on the phenomena that you're measuring. Study level constructs, of course. You can have custom screening questions, and you can have also participant data. Like if you're using an online panel, you could make sure that you're using people who have had good approval ratings or prior submissions. It's kind of like vetting the quality of your participants. One technique that I've heard, so this is the podcast. I'm sure many of you have listened to some of these episodes by Nick Berente and Jan Grecker, this IS Research podcast. So this was an episode, I think, with Jason Thatcher, who was recommending to use two-stage screening. So in using Prolific, they did his team did a pre-survey in which they qualified the panel. So they asked a question, to pre-screen, and then in the main study, after a few weeks, when they invited the selected participants to the main study, they asked that same question within a bunch of other questions to verify consistency. So that's a clever technique where you can also kind of increase the confidence in the results. Think about designing your context scenario. So like I said, in study 1, we created a scenario in which you imagine that you inherited a specific amount of money and you needed to interact with an AI agent to help you invest the money. In study 3, we provided a scenario in which you're given a topic about a specific topic. We had to vet that topic and try different topics in our pre-tests. And your task was to write an essay about that topic. All right. Sometimes you need to provide familiarization and training before you actually do the study, because if people are not used to the interface, the answers that you're measuring might be affected by the fact that they don't know the interface. So we provide sometimes a video, or we provide like a practice session. Like here, for instance, we told them, like this is what the interface looks like. This is what you do. Try out the text output, type something, submit it. So that by the time you're doing the actual task, you have an idea. You've become familiar to the task before you do it. All right. Compensation. This is a big topic. I'm just gonna, not gonna talk in detail now, but think about the base compensation. Think about bonus. If participants don't answer the survey carefully, but there is compensation, you can't say, all right, I'm not gonna pay them anything. If you provide a base compensation, you have to pay it, but then at least when you see the results, if there's careless responding. I'll talk about that a bit shortly. And then maybe you could give a bonus to high quality responses to increase the likelihood of responding carefully. All right, last topic.
Okay,
Yes.
we only have one, or soon to be 1 minute left. Just say it.
Yeah, almost done. Absolutely. So data quality, so pre-tests and pilots. So extremely important that you do pre-tests, you do a pilot test. I'll skip through some of the details here. Check for compliance. So you can have attention checks. You can check randomization, whether the randomization worked or not. You need to check the manipulation, and you need to check for compliance if they actually adhered to the manipulation that you wanted. This is a good article on attention checks. So I tend to always include attention checks. So here, in one of my questions, I'm asking the participants to choose a particular response. Okay. Randomization checks. So you just want to measure on some key demographics if the groups, control group and treatment, you don't have significant difference along those key variables. Manipulation check is where you're trying to see if your manipulation was actually experienced by the participants in the way that you think it was experienced. So did the AI agent actually look human or not human? Okay. Sometimes you could have objective manipulation check. Like in study 3, we looked at actually how did they use the generative AI assistant? Did they actually use it just for editing, or did they use it for something else? You can measure passive compliance, like the timing, how quickly respondents responded to the survey, and so on. Last thing is generative AI. I'll make this very quick. So you can use Gen AI in your experiment in different ways. This is a very nice, preprint study that you can read, Jerry Kane and colleagues, about different ways of using Gen AI. We've used it in multiple ways. We've used it to generate the stimulus. So we use generative AI to help us generate the social script and the list social script. We've used Gen AI as actually the subject of the treatment implementation. So 5 different Gen AI modalities, study 3 that I talked about. I've used Gen AI to help write code. So this was a study on TikTok, diffusion patterns on TikTok, to write code to extract data from the different databases. I've used it for exploratory data analysis, so to show kind of, like the preliminary insights from the data, and so on. All right, so I'm gonna close here. This is my last slide. These are just some key takeaways that I've been talking about. In conclusion, empirical results are only as strong as the design that produced them. Thank you very much for bearing with me. Do you have any time for questions, TC, or?